Hello students, welcome to another class after a long break. In this class, we will continue our study on the chapter number 2, that is solution. In this chapter, we are going to discuss about solubility. So let us first see what is solubility. Solubility is the maximum amount of solute that can be dissolved in a solvent at a specified temperature. That means if the temperature changes, the solubility of the solute in the solvent also changes. For example, let us take two beakers. One is having cold water and another beaker having hot water. If we add salt in both of the beakers, the amount of salt dissolved in the beaker containing hot water is higher compared to that of cold water. That means the solubility of sugar or salt is higher in hot water than cold water. We all know that salt is soluble in water, but in the same, if the amount of water is same, then the amount of salt that can be dissolved in hot water is much higher than that of cold water. So that means if temperature changes, solubility changes. That means solubility is affected by temperature. There are some other factors which affect the solubility of solute in solvent. These are nature of solute and nature of solvent. Second one is temperature. Third one is pressure. These factors affect the solubility of solute in solvent. In this video, we will discuss two types of solutions. The first one is solubility of solute in liquid solvent, and the second solubility of gas, which is solute liquid solvent. So let us first see the solubility of solid solute in liquid solvent. Solubility of there is a saying in case of solubility. The saying is light dissolves like. That means it is related to the nature of solvent and solute. Related to the nature of solute and this saying is directly related to solute and solvent. Okay. So, if the solute is polar in nature, then it dissolves in polar solvent. Okay. Let us see with the help of an example. Salt and naphthalene. These are two solutes which we are trying to dissolve in water. Both of them we are trying to dissolve in water. The salt is polar solute. Okay, it is known as polar solute. On the other hand, it is non-polar. Water is a polar liquid or polar solvent. So when we add salt in water, it dissolves in water. Salt dissolves in water. But on the other hand, when we add naphthalene in water, it does not dissolve in water. Since it is polar. So, salt dissolves in water. On the other hand, naphthalene is non-polar and water is polar. So, they are not like. Here it is saying that like dissolves like. It is polar, it is also polar. So, they are same. So it dissolves salt. On the other hand, they are not like, or they are not alike, their nature are different. It is non-polar, it is polar. So naphthalene is not soluble in water. So we can say that salt is soluble in water. Why salt is soluble in water? Since salt is a polar solute and water is a polar solvent. They are of same nature. So salt is soluble in water. Okay. On the other hand, naphthalene and anthracene. Naphthalene and anthracene, they are non-polar, are soluble in benzene, which is also non-polar. We see that naphthalene is insoluble in water. Similarly, salt is insoluble in benzene, since salt is polar and benzene is non-polar. So we can conclude that why salt is soluble in water? Since both means since solute and solvent both are polar, and in this case both are non-polar. A question may come in exam: why salt is insoluble in benzene? So what is the reason? Since salt is a polar solute and benzene is a non-polar solvent, their natures are different, so it is insoluble. Okay. So here we have discussed the effect of solute and solvent. Okay. The next effect is, we have said, temperature. How temperature affect? Let us see. This is the effect of solute and solvent, or nature of solute and solvent. The next point was effect of temperature, right? Effect of temperature on the solubility of solid liquid. Here write, generally what happens, if the temperature is increases, the solubility also increases. But this is in case of endothermic reaction. We know about endothermic and exothermic reaction. Endothermic reactions are the reactions which require heat to proceed. On the other hand, exothermic reactions are the reactions which need or which releases heat. So write, the solubility of solid increases, the solubility of solid in liquid increases as the temperature increases. For endothermic reactions, and the second case, the solubility of solid in liquid decreases as the temperature increases. For exothermic, this is very important. You have to know that normally the solubility increases with increasing temperature, but this is for endothermic, and for exothermic it is opposite of endothermic. Okay? For exothermic, temperature increases, solubility decreases. Okay. Now let us see the effect of pressure. Okay. In the case of solid and liquid solution, there is no role of pressure, because we know that solid and liquid both are incompressible. They cannot be compressed. Only we can compress the air or gas. So here we can write that there is no effect of pressure in case of solubility of solid in liquid, since liquid and solid both are incompressible. Okay, now let us move to the solubility of gas and liquid. Okay, students, now see, here we will discuss the solubility of a gas in liquid. Okay, in a container, closed container, we have taken a mixture of gas as well as a liquid. It is a mixture of gas as well as liquid. This portion is liquid. So what we have seen in this case, these gas particles are moving in the space above the water, and they are exerting a pressure. Okay, and in this case what happens, we apply some pressure. When we apply some pressure, the piston or the cover of the container falls down. Now the space is decreases compared to the space in the beaker number A. This is beaker number or container number P. Here the space for gas particle is very low. So the difference between these two is that the number of air molecule or gas molecule is same, but here it is more dense compared to this. So here we can write that more number of gas particles are present in per unit volume compared to then container number A. So when we apply pressure, the density of gas particle or air particle increases, so their solubility or their tendency to mix with water also increases. Here they can move randomly in a large space. So the entering of gas particle or mixing of gas particle is very low compared to this. इसमें क्या हो रहा है, गैस पार्टिकल बहुत ज़्यादा स्पेस में मूव कर रहा है, तो यहाँ पे इजीली एंटर नहीं करेगा. लेकिन अगर यहाँ पे प्रेशर ज़्यादा दे दिया तो सेम अमाउंट ऑफ स्पेस में क्या हो रहा है, अमाउंट ऑफ गैस ज़्यादा हो रहा है. अमाउंट ऑफ गैस सेम है, इसमें भी जितना था इसमें भी सेम है, लेकिन इसमें स्पेस ज़्यादा है, इसलिए ये लोग रैंडमली मूव कर सकता है. और इसमें क्या स्पेस कम है तो रैंडमली मूव नहीं कर सकता है, और ये क्या होगा, इसमें डिसॉल्व हो जाएगा. सो हम लोग क्या बोल सकते हैं इससे, द सोल्युबिलिटी ऑफ गैस इंक्रीजेस इन लिक्विड ड्यू टू द इंक्रीज इन प्रेशर. सो यू कैन से दैट the solubility of gases in liquid increases with the more number of gas particle enters to liquid, and hence the solubility of gas increases. And what happens if we increase the temperature? See, if we boil water, what happens? Water transferred to vapor phase. So similarly, in this case, what happens? When we increase pressure, the gas present in the liquid is escaped from the liquid. The gas which are present in the liquid will escape due to the increase in temperature. So in this case, if pressure increases, solubility increases. And point number 2, this is right, point number 1, and point number 2 we can write, if temperature increases, the solubility of gases in liquid decreases. So it is proportional to pressure and inversely proportional to temperature. So a scientist called Henry gives a conclusion by saying that the partial pressure of a gas at the vapor phase is proportional to the mole fraction of the gas in the solution. इसका मतलब क्या है? देखो क्या बोला है? The partial pressure of the gas in the vapor phase is proportional to the mole fraction of the gas in the liquid. So ये केस में क्या होगा? इसमें अमाउंट वॉल्यूम कम है और नंबर ऑफ गैस मॉलिक्यूल ज्यादा है, तो ये क्या करेगा? यहाँ पर प्रेशर भी ज्यादा होगा. अगर प्रेशर ज्यादा होता है तो क्या होगा? इसमें नंबर ऑफ गैस पार्टिकल एंटरिंग टू द लिक्विड, इसमें क्या होगा? ज्यादा गैस पार्टिकल इसमें लिक्विड में जाएगा, इसमें क्या होगा? नंबर ऑफ गैस पार्टिकल कम होगा. तो जितना प्रेशर बढ़ेगा क्या होगा? उतना गैस पार्टिकल एयर में आएगा और उसका क्या होगा? मोल फ्रैक्शन और अमाउंट इंक्रीज होगा. प्रेशर बढ़ने से क्या होता है? गैस का अमाउंट डिजॉल्व इन वाटर में बढ़ जाता है. इसमें क्या था? फ्यू अमाउंट ऑफ गैस डिजॉल्व इन वाटर, और इसमें क्या होगा? व्हाइल वी अप्लाई मोर प्रेशर, तो क्या होगा? अमाउंट ऑफ एयर पार्टिकल एंटरिंग टू द और अमाउंट ऑफ गैस पार्टिकल एंटरिंग टू द लिक्विड इंक्रीजेस. सो मैथमेटिकली इसको कैसे एक्सप्रेस कर सकता है? मैथमेटिकली इट कैन बी एक्सप्रेस एज P इक्वल KH x. x क्या है? मोल फ्रैक्शन और द अमाउंट ऑफ गैस. P क्या है? पार्शियल प्रेशर. ये दोनों लिख चुका है. नाउ KH is what? It is Henry's law constant. KH is Henry's law constant. If the value of KH increases, the amount of gas dissolved in water decreases or liquid decreases. Okay, so we can write if, okay, I will have this. So here we can write here, if the value of KH increases, then what happens? The amount of gas dissolved in liquid decreases. Or we may say that higher the value of KH, lower the solubility of gas in इसका वैल्यू अगर बढ़ जाता है तो क्या होगा, x का वैल्यू कम हो जाएगा, x के आगे ऊपर डिपेंड है, x मींस मोल फ्रैक्शन मींस अमाउंट, जितना अमाउंट ज्यादा होगा उतना सॉल्युबिलिटी हाई, अगर ये बढ़ जाएगा तो ये डेफिनेटली क्या होगा, कम हो जाएगा, दैट मींस सॉल्युबिलिटी डिक्रीज होगा. ओके, थैंक यू फॉर टुडे.